Welcome back. So our next topic is I would like to talk about what is a decision tree. First, I would like to you guys to watch a YouTube video which you may click for this website to see the videos. Okay, so let me show the videos here. So if you can take a look at in your computers. Okay.
Talk about a different classifier, decision trees. Decision trees work in a very different way from naive Bayes. And the best way to show how decision trees work is to actually start with an example. So suppose I have the following data set. So my task is to predict if a certain guy named John is going to play tennis on a given day. Right? So to help me with that, I've observed John over a number of days and recorded various things that I think might influence John's decision to play tennis. Right? So I looked at what kind of weather it is. Is it sunny or is it raining? Right? Humidity, is it high? Is it normal? Is it windy? Right? And whether John ended up playing on that day. So that is my training set. Those are the examples that I'm going to build a classifier from. And the question is, okay, a new set of data comes in, right? So on day 15, it's raining, the humidity is high, it's not very windy, so is John going to play or not? Right. And just by looking at the data, it's kind of hard to, it's kind of hard to decide, right? Because it's, some days when it's raining, John is playing. Other days, John is not playing. Sometimes he plays with strong winds. Sometimes he doesn't play with strong winds and with weak winds. Right? So what do? How do you predict it? And the basic idea behind decision trees is to try to, at some level, understand why John plays. So this is the only classifier that we'll cover that tries to predict John playing in this way. And by understanding, I mean what decision trees are going to do is they're going to take a look at each one of these attributes, the weather, the humidity, the wind, and try to make the best inference possible about, assuming that it's raining, is John going to play or not, with what chance and what other factors may influence John playing if it's raining. Right? So in general, what the algorithm is going to look like is it's going to look at the different attributes that you have in your data, use those attributes to split the data into subsets. So for example, if I'm looking at the outlook, right, it could be raining, or it could be sunny, or it could be overcast. So those are three different subsets, and you will have some examples in each one of those subsets. And if some subset is pure, then that's great. So if John always, for example, plays when it's rainy, then we stop. Otherwise, we keep going. We look at a different attribute and try to split the data further. So it's a divide and conquer algorithm of sorts. I guess you could, not really, but you could say it that way. And then when we have a new data set, what we're going to do is when we have a testing example for which we want to make a prediction, we're going to look at which subset that example falls into and then use the dominant class in that subset. So if this falls into a subset where John always plays, then we're going to say, yes, he will play on that day. And if not, we'll say no. So that's at a high level. So let's look at how it operates. So suppose we take Outlook as our first attribute, right? So here's the Outlook attributes. There are three types of Outlook, right? It could be sunny, right? And if it is sunny, then these are the training examples that correspond to a sunny day, right? So do you want D8? So you can just look on the previous slide and see, right? Sunny, sunny. Sunny, right? So we just look at all examples when it was sunny, and you see that okay, for some of them John played. In fact, 2 times John played, and for 3 of them John didn't play. Okay. Now it could also be overcast, and these are the examples for overcast, or it could be raining, and these are the training examples, the training days when it was raining. So So we look at them and start counting. In this subset, when it was overcast, all days when it was overcast out of my training data, John ended up playing. Right? So this is what you would call a pure subset. It's a subset where you have only positive examples or only negative examples, but not a mix. Right? So you have 4 yeses and 0 nos. When it was sunny, it was 2 yeses and 3 nos. When it was raining, it was 3 yeses and 2 nos. So the way the algorithm is going to proceed is it's going to say, this is a pure subset. We don't need to split it any further. So if it's overcast, we just know that John plays tennis. But if it's sunny, there's still some uncertainty. Right? So what we need to do is we need to figure out a way to split this set further so that we can get pure subsets. Right? So let's take this subset when it was sunny, and let's assume that we're picking humidity as our next attribute to split on. It looks good, right? So you split on humidity, and you end up with 2 sets. Humidity is either high or normal. Whenever it was high, John didn't play, and when it was normal, John did play. Okay? So now we have 2 pure subsets, and the algorithm would stop at this point because there's no need to divide the data further. So then you do the same thing on the rain, and let's say you just take the wind for the whim of it, right? So you take the wind, you break on the wind, and for the wind is either weak or strong, and when the wind is weak, John plays. When the wind is strong, John doesn't play. Okay, that's it. The algorithm is done, because at this point, what you've done is you've taken your training set and you have sorted it into pure subsets based on some attribute values. Right? So now there's no need to try to split it any further. Good. So the resulting decision tree from this would be something like that. Right? So what you do is you just replace the list of examples with the decision that your algorithm would make. So everything here was negative, everything here was positive. Question? How do we select which attribute?
Okay, so welcome back. So you have watched the video to talking about the theories about how to decide the decision tree, but there are only 14 records, right? But how about our data set? For our data set is more than, let me see, what about the data set for us? So the data set for us are more than 45,000. 我们有45000笔的资料。It's too much for us to make the decision for us. There are only 14 records. 只有14笔的资料。It's easy for us to calculate, to draw the decision tree only for 14 records. What about 45,000 records? It's impossible for us to draw, to make the decision trees. So that's why we have learned Python to make the diagram, the decision diagram for us. So that's why the next process is help us to understand how to do the process to do the decision tree, the process for the decision tree. So for our data, we spread with 2 categories. One is for continuous variables. The other is category variables. But for the category label variables, we have to encode the data. So the next step is help to teach you guys to encoding the category variables, because the category labels we have split to different columns. If the category has 4 labels, we have split it to a different 4 columns to present these category variables. Okay, so next our examples for how to encoding category labels first for our decision tree diagram. Okay, so here is the list for our columns and the describe for the continued variables. Okay, so let's for the list for our describe, this is continued variables, so rest the variables are category, so we have to list all the category variables as a vector, a category variables like this one. So we keep all the category variables name like job, marital, education, default, housing, loan, contact, month. So there are all category variables names. Okay, so let me show the variables for this. Okay, so the first thing we have to transfer the months as January, February as 1, February as 2, March as 3, all the way to December as 12. So we to translate the category to numericals. Okay, so here is the process. So first we have to set the orders for our months, January, February, March. What about the first one? First one is January. What about the third one? The sixth is July. Okay, so the index is 6 in July, plus 1 is 7. So we have to apply the month's index plus 1, because July the index is 0. We have plus 1 to identify with 1. What about June? June is 6. Okay, so the index for 0, 1, 2, 3, 4, 5. For June, the index is 5. So we have plus 1 to identify with 6 index. Okay, so we have to apply the lambda function for months. Okay, so here we change the category with numericals, like the May. Okay, so it presents by 5. So here we how many unique for our months. Okay, the count. So you may see from the January to the December the count for each month. The job, numericals. Okay. Okay, so for the category variables, we have to use the one-hot encoding to separate with a new column for each label of the categories. So each column we present by 1 of 0. Thus this label does it shows yes or no. Okay, so we use this one to get dummy function to create the dummy variable for the job variable, which the job variable is a category variables. So we use this one is provided by pandas function. So pandas function get the dummy function, get dummies, and we use to separate the labels for job. So here you can have the result to save the job encoding df. So you may see the first lines for each one. So here, because there are 12 labels for the job 一共有12个 label. Okay, so you may see here job encode head df job, this one, job encoded. So you may see here what is the dummy variable for job. So there are 12 labels for the job. So we spread one column with 12 column like this one. So each column present only one status for the records. Management with one. This one presents by technician. And this one is management. So each record only presents one label for each job dummy variables. Okay, so you just keep in mind. So we separate the labels for category. So there are 12 labels in job. So we separate with 12 columns with the job titles. Okay, so here is the how we create the dummy variables for each category job. Okay, so here you may find the colors for our job titles. Admin blue color. Okay. Okay, so here we have to redefine the color name. We just use the color name. We use the job of something. We just use this one. So you can see the detail. So we just use the job admin. It used to be admin blue color. So we just add the part for job. Okay. And also we have to combine this data frame. Combine this data frame with our original data frame. So original data frame df, you may see here df, this one, only with 18 variables. 有18个变数. So here I would like to combine the original df with job encode df. This one, job encode. You may see here with the same records. This one. So these two data frame with the same records, 45,211 records for each. So with this context, so we combine these two diagrams together. So later, this diagram should be 18 plus 12 columns. So will be 30 columns for the new category, for the new data frame. Okay. So you may see here the data frame is to from 18 to 30. Okay, so let us take a look at the new data frame we just created. Okay, so used to be y is the last variable for the df, but right now we append, so we add extra colors which is present the variables for job. dummy variables. So there are 12 variables. Okay. Okay, so we do the same thing as maritals. So how many maritals? The status. So you can see here. There are 3 status for marital. First one is divorced. The second is married. The last one is single. So we combine these 2 data frame again. So DF right now with 30 variables, and plus this marital in encode DF, this one marital. Okay, so only 3 colors. So we have to this combination. So the new data frame for DF should be 30 plus 3. So we will be 33 colors for the new data frame. Got it? So right now it's 33 variables. So the last 3 variables are maritals, 3 status. Understand? Okay. Okay, so here we have to do the housing, doing the same. Okay, housing variables, and use to the long variables, doing the same. Okay, it's time for us to input our variable x. So this x variables is our variable for x. So how many variables? So we use the continue variable first. So for age, balance, campaign, previous, housing, there are all here. Housing we use 1, right? Housing right now is 1 and 2. So variables. So we because the housing used to be yes, and we replace yes with 1, no with 0. So here you can see the df function, df data frame for housing. So here housing and loan right now is continue variables 0, 1, 1 of 0, 1 of 0, this one. Okay, so here are all numericals x variables. 所以这些呢都是连续型的变数。And also we use this one for job encoding, for marital encoding. So you can see here is the feature we are going to use. So you may find the features. So the features, so you can see here are category numericals variables. So here are category variables. This one here for job, here for maritals. So with these examples, so next, if you want to analyze with category label, you will do the same process to encode the category variable first. Okay, and next we have to announce, to define our target variables. So our target variables is conversion, right? These conversion variables. So here is conversion. Okay, so right now we have to import a scikit-learn. So what is the scikit-learn? Okay, scikit-learn is a machine learning model for Python. So it's a machine learning in Python. So it provides a lot of machine learning methodology for Python. So we have used before, like regression, right? So next in the future I will teach the clustering 分群. So right now it's classification 分类. So there are 3 types for the scikit-learn model. Okay, so first we have to import the scikit-learn model first. Okay, and then we use the scikit-learn, right? Scikit-learn, we import the tree function. Okay, so we use the tree. It means decision tree, 决策树. Okay, so tree, we use the decision tree model. And the classifier, decision tree classifier. Okay, so this model. We also use the maximum dip as 4. So like the tree, we only have 4 levels for our decision tree, not too deep. Okay, so have this model ready, and we build the model with this one, decision tree underline model. This is our model for decision tree, and then we use this model, right, and to build the decision model, to create the model for decision tree, like the video. Okay, so the videos we try to solve, does the John play tennis or not by human being, only 14 records, 只有14笔的资料去做, but it's impossible for us to predict the records more than 45,000 records. 好，45,000笔的资料，我们人没有办法去预测。And okay, so to fit is to build the model. The first part is our figure. Figure is the x. So you know the x, right? For the x value, like this one: age, balance, campaign, previous housing, all the way to the job and marital status. And for the first part is the x, and the second part is our target variable. So what is the target variable? Our target variable is conversion. Did the client buy our term deposit or not? So you have to know to build a model is so easy. You just to import the required decision tree model, and to have the model ready, and to fit the x and y, and then Python will build a model for us. Okay, done. So the model right now is done. Okay, so later here we are going to visualize the tree, the decision tree. First you have to import this diagram, this module. If you didn't import this package correctly, so you may find some errors. So you have to import this one. With this one, so you can here to anaconda install Python grphyz, like this way, to install the package for you guys first, if you didn't install this package. Okay, right now, okay, so you need to restart. Okay, so because I have import this before. Okay, import. If you didn't import this module, so you have to reinstall this software, and then we have to build the diagram. Okay, here comes our result. So this diagram is much complicated than the John play tennis. Okay, so with this diagram, here is our root, and for the bottom, so we call lift. So here is our root node, 根节点, and in here we call leaf, 叶节点. So it's like a tree, upside down tree. So next we have to explain the meaning for the tree. So how many variables we have to input as a y of our x? So it used to be, let me see how many variables. More than let me see here. Did I show? Okay, no, more than 12 x as our input. So here it dominates. The most important value is previous, this one. So here you can use the decision tree to make a prediction. If the previous these variables is less than 0.5, so it go to the left. True, right? If the previous is bigger than 0.5, it go into the right hand side. Okay, let me have the example going to the right hand side. If the previous is bigger than 0.5, it will go to the left hand side here. And then you will find the second criteria for housing. Does it has the housing? If the housing is bigger than 0.5, here is less than, right? Is housing less than 0.5, it means 0. If it don't have any housing, so it going this way. If you go in this way, is the housing is 1. Okay, so the housing 1 is bigger than 0.5, it will go in this way. Okay, here this way you will have the third criteria for age. If the age is less than 60.5, it go into left this way. If the age is more than 60.5, bigger, it's older than, it go in this way. And then we'll come to the fourth criteria. It will check the balance. If the balance less than 4660.5, it will go in this way. And you may find the conclusion for this status is yes. If the balance is more than these numbers, it go into this way. It will not buy your term deposits. So here you may see the decision tree, the different situation with different criteria. Okay, I hope you can copy this file. Okay, so you maybe, let me save image. You can save this image as feature use to save this one. Let me see, to save the decision tree. Okay, let me see. decision tree diagram, D-I-A-G diagram. Okay, so later we'll find this diagram. Okay, so let us go back to here. So you may find the data, the diagram. So where is the diagram? Machine learning, this one. Decision tree, let me see, decision tree, this one here, I just created. Okay, so you may find the whole diagram for decision tree. It's pretty much complicated than the John play tennis. So you have to look at the criteria for, so how many variables we are going to consider. So the previous, housing, balance, okay, so job, self-employment, this one. Okay, so the data, the variable shown on the decision tree is the most important factor for our conversion Y. Okay, so that's all for the course for today. But I think maybe it's hard for you guys to understand the decision tree. But for the next lecture, I maybe have more simple examples for decision tree. But basically, we use the decision tree for classification problem, to solve the classification problem for machine learning. 所以说我们用决策树呢来去做分类的问题。So we use this variable to judge, to predict the customer buy your term deposit or not. Okay, so that's all for today's course. Okay, see you guys next week. Okay, so the rest of the source code, so let me see. Okay, so for the discussion, so you have to follow all the source code, so you can have exercise with another example, which code is Iris. Okay, Iris dataset is a simple example for machine learning. Okay, I hope you guys can understand what did I talk for this week's class. Okay, see you guys next week.